Alright, so now let us talk about some properties related to the triangles, okay? So the first, let's take a triangle A, B, and C. And the one property is that sum of all interior angles in a triangle is equal to 180 degree. So what are those interior angles I see in this diagram? I see that there is angle 1, 2, and 3. Now these three interior angles, they could be of whatever measure, whether it is an obtuse triangle or a right angle triangle, it doesn't matter. What matters is the sum of these three angles is always going to be equal to 180 degree. Okay. And the second property is related to the side length. It says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Meaning, with reference to this triangle, if I take, let's say, segment AB and if I add to it the segment BC, then this is going to be greater than the third segment, which is AC. You could pick any two dimensions and it should be greater than the third dimension. If that condition doesn't hold true, that means you cannot construct a triangle out of three line segments. Okay. With the help of these two conditions, we can solve many problems in geometry related to triangles. And in addition to these two properties, we are going to be discussing one most important property that is in triangles, okay? And it is specifically related to a right angle triangle, okay? So let me define my right angle triangle first. It is P, Q, and R, all right? And it forms a right angle or an angle of 90 degree at the vertex Q. And in this triangle, we are stating that, let's say the line segment PQ is equal to the height of the triangle, correct? And the segment QR makes the base of the triangle, and the respective lengths of these two sides are H units and B units. And then we say that the third segment, which is the segment PR, which is directly opposite to the vertex where the 90 degree angle is being formed, it is known as the hypotenuse. Let's say the dimension of this segment PR is equal to C units. So the third principle that we are going to talk about is known as the Pythagorean theorem or the Pythagorean principle. Okay. So let's say it is Pythagorean theorem. We are stating that in the case of a right angle triangle having the respective dimensions of the height as H, the base as B, and the hypotenuse as C units, the Pythagorean principle states that the C square is equal to H square plus B square. So this is our Pythagorean theorem. Now with the help of these three properties, 1, 2, and 3, we can basically solve any problem related to triangles. Okay, so let's go take a look at some examples and how we apply these fundamentals to solve whatever is unknown in a triangle. Now let us take a look at one example here. We are given an isosceles triangle. Find the values of angles X and angle Y that is unknown in this triangle. So we look at this triangle A, B, and C. There is one angle given to us that is 40 degree, but we do not know the values of the angle X and Y, right? But we also know that this is an isosceles triangle. Well, the first thing what you need to find is that in this triangle ABC, the one which is an isosceles triangle, which two sides are equal to each other, okay? But we also notice that there is a sign here that shows double bar here, right? Those tiny little lines. What these lines indicate in a triangle that these two sides are equal to each other. And that means that segment AB is equal to segment AC, right? So if that is the case, we say that the angles that are formed directly in front of these sides or directly opposite to these sides will be equal to each other, meaning the angle B will be equal to angle C. And that is the property of this isosceles triangle, right? But we are given angle C already, right? Angle formed at vertex C, right? So that means they both have to be equal to 40 degree. So that gives us our angle B. So this is 40 degree and that is the value of angle X, the one that was unknown to us, okay? Now we need to find the third angle, right? But we also know that the sum of all interior angles of a triangle is equal to 180 degree, right? That means angle A, which is Y plus 40 degree from angle B plus 40 degree from angle C, it should be equal to 180. Or in other words, Y should be equal to 180 minus 40 and that will be simply 100 degree. Okay. So with a simple application of the angle sum property and the properties of the isosceles triangle, we were able to find all the unknown values of angles in this given isosceles triangle. Okay. So let us take a look at another problem in which we are stating that a 13 feet long ladder is placed against a wall such a way that the foot of the ladder is 5 feet away from the wall, which is the wall here. This is the vertical wall here, and then this foot is 5 feet away. Okay. And we want to find out up to what height does the ladder reach the wall, and we have been given the length of the ladder as well. Okay. Now you can apply the Pythagorean principle here, because this diagram, the one that is shown here, it is very much a reflective of a right angle triangle, right? And then we have a diagonal. We have been given the dimension of this diagonal. Let's say this is C, and then the base is 5 feet and the height is what we need to find out. Now, based on the Pythagorean principle, we can state very clearly that the C square, the one which is the hypotenuse, is equal to the square of the height plus the square of the base, correct? And C is 13 feet. So it is 13 square is equal to, let's say h square is what is unknown to us, but the base is 5 feet, and that will be 5 square. Or in other words, you can state that h square is equal to 13 square minus 5 square. So let us solve this squaring and subtraction. So let's say 13 square is equal to 169 and 5 square is equal to 25. So this gives you 144, correct? So h square is equal to 144. Now if you take a square root on both sides, that means you can also take a square root of 144, and that will give you equal to h is equal to square root of 144 will be 12 feet. So that is your unknown dimension that you are supposed to find. So in this specific arrangement, this ladder will go up to 12 feet high from the base, right? So this is 12 feet. Well, this was a quick example of the application of the Pythagorean principle, and we also learned about the few properties in triangle. Okay. With that, we conclude our discussion on the introduction of triangles and discussing about the properties of triangles. And you should practice a little bit more using your quiz and exam modules.